O vídeo a seguir não é indicado para quem é idiota e acredita na Terra plana.
Saudações siderais! Estamos começando mais uma edição de Conexão Sideral. E hoje, para comemorar os 40 anos da missão mais espetacular já realizada na história da exploração espacial. E é uma missão que ainda não acabou. Estamos falando das sondas Voyager 1 e Voyager 2. Elas foram lançadas em 1977, 40 anos atrás. A Voyager 2 foi a primeira a partir da Terra e saiu no dia 20 de agosto. 2 semanas depois, partiu a Voyager 1. E a Voyager 1 era 1 porque, apesar dela sair depois, ela ia chegar primeiro a Júpiter e Saturno. A Voyager 2 ia passar por Júpiter, Saturno e, se aguentasse o tranco, iria até Urano e Netuno. E foi exatamente o que ela fez. Passou boa parte da década de 80 viajando pelos planetas e aí, a partir de então, passou a uma jornada interestelar em busca do espaço interestelar, quer dizer, os limites de onde o Sol exerce sua influência e onde começa o vento interestelar, a radiação emitida por outras estrelas, a predominar sobre a radiação solar. Uma região do espaço que foi atingida pela Voyager 1 em 2012 e deve ser atingida nos próximos anos pela Voyager 2. E para comemorar esse grande evento, hoje nós vamos conversar com Ed Stone. Ele é o cientista-chefe da missão Voyager, isso desde os anos 70. Se juntou à missão em 1972, 5 anos antes dela ser lançada, e está trabalhando como cientista-chefe da Voyager até o presente momento. Vamos comentar sobre todos os feitos da missão ao longo dos últimos 40 anos e o que vem por aí. Quais são as perspectivas para os próximos 10 anos, que é basicamente o tempo que vai levar até que o suprimento de energia da Voyager, que é baseado num gerador termoelétrico de radioisótopos, basicamente uma pilha de plutônio. Esse plutônio vai emitindo radiação, isso gera calor e o calor é convertido em eletricidade para a espaçonave. Mas conforme o plutônio vai decaindo, vai diminuindo a quantidade de calor que ele produz e, por consequência, vai diminuindo também a quantidade de eletricidade disponível para a espaçonave. Ela tem aí mais uns 10 anos de operação, mas depois disso vai ter que ser desativada. E aí vai permanecer como um objeto inerte, rumo ao espaço interestelar, em sua órbita própria ao redor da Via Láctea, vagando pelo espaço por bilhões de anos e levando uma mensagem muito especial das pessoas que a construíram, da humanidade. E nós vamos conversar sobre tudo isso com o professor Ed Stone. Agora só uma ressalva, que infelizmente a gente não conseguiu, ele não conseguiu ativar a câmera dele, então não tivemos o vídeo dele falando, tivemos apenas o áudio, e para compensar isso eu editei o material com algumas cenas de arquivo da Voyager, que mostram não só o lançamento, a construção, mas também as imagens que a Voyager obteve dos planetas em sua passagem por Júpiter, Saturno, Urano e Netuno. Também algumas animações que mostram a missão interestelar. Espero que isso mais ou menos compense a falta de imagem do Dr. Stone, mas ele foi muito solícito e nos atendeu aí em meio às comemorações do aniversário de 40 anos, o que foi realmente muito bacana. Então, confira aí o papo todo que eu tive com o Dr. Stone.
Well, first of all, I'd like to take the time to thank you. I already wrote you about this, but you know, I remember as it was yesterday the images from the Uranus flyby in 1986, and I was 7 years old, and that impressed me very much, and certainly helped foster appreciation of science and space exploration that carved my path to this day as a science communicator, and this is all because of your great work with Voyager. So I'd like to take the time to really say I appreciate that, and that is a huge honor talking to you today, you know, celebrating the 40th anniversary of this great journey, which is the Voyager mission. So thank you very much for taking the time to talk to me.
Certainly, I'm very pleased to be able to do it. It's been a remarkable mission to have been with all these years, and there's still more ahead.
Yeah, and you know, 40 years. So since its early planning, Voyager was supposed to be a long-lived mission, right? But
yes.
Did it ever occur to you back in the 70s that it would be ongoing for as long as it did?
Well, when Voyager was launched, the space itself was only 20 years old. So really there was no basis for believing anything could last 40 years. In those days, spacecraft lasted a few years. That's the reason we built two, to assure with some high probability that at least one would make it to Saturn in 4 years.
So that was basically, you know, the top goal was to reach Saturn. If you got a Saturn, you were happy already, right?
Yes, that was mission success. But of course, we launched in 1977 so that we were ready to take advantage of that if everything was working, and everything continued to work.
All right. So, well, it will be really hard for another space mission to get as many firsts as Voyager. But, you know, from all its accomplishments, is there anyone that sticks closer to your heart that you appreciate the most? What was your favorite Voyager moment?
Well, the one which I think I always point to is the discovery of active volcanoes on Io. Before Voyager, the only known active volcanoes in the solar system were here on Earth. And we weren't prepared for the fact that just a moon of Jupiter, the moon about the size of our moon, would have 10 times the volcanic activity of the Earth. It really set the stage for what was ahead. That is, that nature was going to provide us with a lot of surprises, which it did time after time.
And it's interesting that you mentioned surprises because, you know, you had a setup that had twin spacecrafts going to Jupiter and Saturn and arriving a few months apart. How much of an advantage was that, you know, to have a first mission that has a look around, and then how much that guided the planning of observations of Voyager 2 after Voyager 1 was already departed from that system?
We did prepare each encounter we had the months ahead to prepare the sequence of events, as it was called. And we had only 3 months between Jupiter 1, Voyager 1 at Jupiter, and Voyager 2 at Jupiter. But in that time, we did manage to insert some new routines. And for instance, we made a movie of some of the plumes, volcanic plumes on Io. So we did make some adjustments between Voyager 1 and Voyager 2 at Jupiter. At Saturn, our Voyager 1 told us that we would not be seeing the surface of Titan, the moon of Saturn that has a very dense high nitrogen atmosphere, but you can't see through it visible. And so we did what we could with Voyager 1, and that allowed us to keep Voyager 2 in the plane of the planets and head on to Uranus and Neptune and not worry about Voyager 2 trying to get closer to Titan or do anything additional with Titan.
Yeah, and I'd like to ask about this aspect of Titan as well, because of course you couldn't predict in foresight, and Titan was very interesting because it had a dense atmosphere. But after all happened, do you think the choice to prioritize Titan was a good one? Because I heard there was a possibility of not going for Titan, but going for Pluto. After the fact, I know after the fact is very difficult to say, but was it worth to prioritize Titan for Voyager?
Well, Titan was obviously only 4 years from launch. Pluto would have been 12 years from launch. And so one would be trading something which we thought was reasonably likely to occur to something which was less likely the spacecraft could last long enough. And so then Titan we knew had an atmosphere, methane in the atmosphere, natural gas. We knew that from Earth observations. What we didn't know was it had a very dense nitrogen atmosphere. And that told us that Titan would be a very interesting world where the chemistry occurring there today is similar to that which occurred here on Earth before life evolved and created the oxygen that we all breathe.
So it was a very important target. And do you feel Voyager paid off in this respect? What could we discover with Voyager about Titan that guided, for instance, this new exploration with Cassini and Huygens?
Well, we determined that it has a very dense nitrogen atmosphere. We know it's nitrogen. We know its pressure at the surface about 1.5 times that here on Earth. The temperature is about 94 above absolute zero, that there are methane clouds and probably methane rain and probably lakes of methane and other complex hydrocarbons, which we managed to determine some of them with our infrared instrument, which could look at the material that was obscuring our view of the surface, the very dense smog, if you like, on Titan. Just makes it impossible to see through in the optical. You can see through in the infrared, and of course radar, which is what Cassini uses, allows one to accurately reveal sort of the Great Lakes on the surface of Titan. But they're lakes of liquid natural gas, not of water.
And what about Europa? Because Voyager was also instrumental in getting a glimpse that it probably has an underlying ocean inside of the Jupiter's moon Europa. What was your reaction when you saw the images of Europa with that fractured surface?
Well, the fractured icy surface, we knew it was water ice from the Earth-based data actually, but it was fractured, cracked, no mountains, no valleys. It looked like ice pack on a liquid water ocean. And of course here on Earth, wherever there's liquid water, whether it's deep in the ocean where it's hot or whether it's in Antarctica where it's cold, it doesn't matter, there is life, and microbial life. And so that certainly meant that we had one other place in the solar system, at least, where there was, even today, liquid water. But it was beneath an icy crust.
And did you get an itch to get back to those words? Because, you know, all the outer planet missions that are going forward since Galileo and Cassini, and we have new missions ahead of us, they were basically exploring the things that Voyager first glimpsed, right?
That's right. And there is a mission that's being planned now called the Europa Clipper to go back to Jupiter and into an orbit around Jupiter, but one which could loop in and observe Europa up close and then get back out of the radiation environment and then loop in again and do this time after time after time to create an accurate high-resolution map of the surface and to look for places where there may be plumes erupting. There is some suggestion from Hubble Space Telescope that there are occasional plumes, geysers erupting from the icy surface of Europa. That would be very exciting.
Let's talk a little bit about the ice giants, because Voyager 2 was the only spacecraft to visit those, and as you said before, this was not at all guaranteed. How much confidence did you have that you would eventually get to the ice giants with Voyager?
Well, we didn't know, of course. As I said, the space station itself was only 20 years old when Voyager was launched, and Uranus was 1986. That was basically 9 years after launch. But the spacecraft performed very well once they got into space. We have a lot of redundancy on the spacecraft. We have a power supply that slowly but surely decays away, but we knew we would have enough power. Our main challenge at Uranus, and even more so at Neptune, was how do we take images when the sunlight is so dim? We have to have long exposures. How do we make sure they're not smeared because of motion of the spacecraft? So we had to devise techniques on the spacecraft to compensate for that. And we had to improve our ground radio system in order to be able to receive the weaker signals from the more distant planets. So all of that work was done after we flew by Saturn. So we had the time between 1981 and 1986 to prepare for returning images from this even more remote world, and then another 3 years to get ready for Neptune, which is even further away.
So the mission had to evolve along with, its path out of the solar system.
It had to be. When we launched, we had no capability to return any images from Neptune. That all had to be developed after we flew by Saturn and Uranus.
Wow, incredible. And now we have an interstellar mission. And I was wondering, if you didn't take for granted not even Uranus and Neptune. What about the Interstellar Mission? Back then, there was any idea that you could that?
Well, we had hoped we would reach interstellar space. Really, at the beginning, in fact, after we finished the Saturn flybys, the next phase of the mission was called the Voyager Uranus Interstellar Mission. So even in 1981, we were already talking about that as the ultimate objective, was to reach interstellar space. But none of us knew how far that was, and none of us knew that a spacecraft could last long enough. Fortunately, it's not too big. We actually got there in 2012, and the spacecraft is still working today, now in interstellar space. That's Voyager 1.
And how was that transition? Because, you know, Voyager initially was mainly a planetary science mission, and then it became a kind of a heliophysics mission. So how was that transition in terms of teams and instruments? How did it work out?
Well, the instruments we had, 5 of them were fine instruments for the interstellar phase. And 4 of those are working on Voyager 1, and all 5 are working on Voyager 2. Again, this was not an afterthought. This was something which had been thought about in designing the instruments. Now, we had to design instruments that were primarily for the planets, but in fact, they were also designed to be able to accomplish first-order results from interstellar mission.
And I imagine you stuck with the mission for all of those years, and you probably worked with 2, maybe 3 generations of scientists. Did you see any generational difference between the teams that worked on Voyager along the way?
Well, there was, of course, an evolution. In fact, some scientists got their PhDs on the Saturn flybys, and then they came back and worked on Uranus and Neptune. But they were old hands. They'd been there right from the beginning. Actually, we had a team through the planetary phase, which lasted through 1989, 1990. Was a team that really polished the capability to fly these are the first automated spacecraft that flew themselves, and our job was to tell the spacecraft what the sequence of events should be when it got there. And I think that's the science team really did evolve because it learned a lot, and that was important as we took on more and more challenging activities and at these even more distant planets.
And well, at this point, as you said, in 2012, Voyager 1 has left the solar bubble, as to speak. But I was wondering if this was as expected, or did you find surprises along this way?
Oh, there were definitely surprises. For instance, one, you see the sun has this wind blowing radially outward from it, over 1 million kilometers per hour. And then it has to go through a sonic shock because it's a supersonic wind, so it can turn and flow and form a tail behind the heliosphere. So all of the wind coming out from the sun actually ends up turning and going down the tail. But what happened when Voyager 1 got in this region where the wind was turning, it wasn't turning. It was just slowing down. It was in a stagnation region. And that's because Voyager 1 was very near the nose of the heliosphere, where the interstellar wind pushes directly against it. And that was a big surprise. It was we expected the wind to continue its high speed, slower than it had been, but still very high. But it didn't. It just slowed down and finally came almost to a stop. Now, that's not the case for Voyager 2, which is still inside. There, the wind indeed is turning, as we expected, to head down the tail. But Voyager 2 is still inside. We'll see what it's like when we finally cross.
Is there any prediction of when this will happen?
Well, if we look at various things like what's the intensity of cosmic rays which are outside trying to get in, we know what that looks like as we approach the boundary, because Voyager 2 told us what it was, Voyager 1 told us what it was. If we now look at where that counting rate is, how many cosmic rays we're seeing, we say we probably have a couple more years before we reach the heliopause. But it could be different where Voyager 2 is. So we're used to being surprised. We have predictions, but we're always not surprised when they're different than we expected.
And what about New Horizons that is now starting? You know, it has a flyby in 2019, and then it will go out of the solar system as well. It will be useful to understand this whole environment to have data from New Horizons as well?
Yes, it would be, and certainly would be. And I don't know if New Horizons will have the power, enough power from it has a single radioisotope thermoelectric generator. And so it will eventually, like Voyager, will eventually run out of power. I don't know what that limit is, but so it's not, I don't know that it will actually reach interstellar space while it still has enough power.
And how much life do we have on the Voyagers right now?
We have about 10 years. We lose about, each year we have 4 watts less power than the year before. So we're now in the phase, the engineering challenge, one of the engineering challenges we have is what do we turn off? Each year we have to turn something new off, and at some point we'll have to start turning off the instruments because we can't turn anything else on the spacecraft off. All of that is still ahead. It's about a 10-year, it'll take us about 10 years to finally reach the point where we just have enough power to run the spacecraft and no instruments. And that will continue for a while as an engineering experiment, but that will be the end of the science mission. But that's not the end of the Voyager mission. Voyager will continue, the two, in orbit around the Milky Way galaxy every 225 million years, making an orbit around the Milky Way galaxy for essentially billions of years, long after the Earth itself may have been swallowed by the red giant phase of the sun.
That is an amazing thought, and I wanted to ask you about that. This difference between the science mission that will eventually end in maybe 10 years or so, and the ambassadorial mission of Voyager with the famed golden record. And most people think of it as a message to extraterrestrial civilizations, but what gives me the chills is the message it sends to ourselves, right? That a small and beautiful part of human culture will be preserved in some form for millions, perhaps billions of years after we are gone. And I was wondering, how do you feel to be a part of that, and how it was to construct the golden record?
Well, it's exactly right. It really was a message to us, a celebration. We actually had gotten to the point we could send such a message. I really think of the two Voyagers as our silent ambassadors, and the record is their carrying card, their what do you call it, little business card from Earth, saying we came from Earth, we came from this distant place, which may not be there anymore, but this is where we came from. This is where the ambassadors came from.
It's an amazing thought. And how was that constructed? I know Carl Sagan leads a team that built the message. Did you have input? The people from the science team have input in it? How was it constructed?
Carl Sagan was asked to, you see, he and a team had designed plaques for the Pioneer 10 and 11 spacecraft, which were also on the way out of the solar bubble and in orbit, just like Voyager. So he was asked about 6 or 7 months before launch, could he design a plaque for Voyager? And they came back with not just a plaque, but in fact a 16 2/3 RPM two-sided record, grooved record, feeling that a grooved record was a much more durable medium than anything more modern. Electronics would not survive billions of years. It would be damaged by radiation. But a record made out of copper and gold-plated would in fact survive for billions of years. So they came back with this idea of a record which has, of course, sounds on it. It has greetings from many different languages, music from many different cultures, and of course something like 100 pictures of this place. These two spacecraft were developed here on Earth.
Yeah, and I'm happy to notice that there was a little message in Portuguese as well, so I felt represented.
Great.
And well, I'd like to ask you a little bit more about Carl Sagan, because you know he's so much missed as a voice in science, especially these days where we have so much confusion and so much of bigotry against science, and he's surely missed. But you worked with the scientist, not the communicator. I was wondering, what are your thoughts on Sagan as a scientist, and how was it to work with him at NASA?
It was great working with him. He was really dedicated to the search for life, both in the solar system and beyond. He was certainly a key in making that a credible area to pursue, and that in fact there was a way forward. There was a way to collect data that might reveal, and here in this case of the solar system, that there is life if there's liquid water, or that there was life when there was liquid water. And now, of course, in the last 10 or 15 years, there have been discovered many, many other solar systems, other planetary systems around other stars, and none of them look like ours. So that, in fact, the opportunity for learning about the formation of such planetary systems is greatly evolving, and is the opportunity for searching for planets out there which have the right conditions for microbial life, at least, to have evolved and changed their atmospheres in a way that would be a signature that life is present somewhere else than just here on Earth.
Yes, and one thing that I hear a lot is people asking if Voyager cameras could be turned on, and the answer I always see being given is that, okay, we could turn it on, but there's nothing to photograph at this point. And I was wondering if there isn't one last picture to be taken, which would be the sun as just another star in a field of stars. I'm not sure we're far enough to do such a thing, but I'd like to ask you about that. Would that be possible?
No, it wouldn't. You see, these computers are very small. Your smartphone has 240,000 times more memory than the Voyager spacecraft. And so there's no room to store data. It has to be transmitted to Earth. What we did was we took the programs out that ran the cameras and the other planetary instruments, so we could put programs in to optimize the instruments that are now making measurements. And so there's no software on the spacecraft to run the cameras, and there's no software here on Earth to decode the data to make images out of them. That would all have to be redeveloped. But right now we would not have the power any longer to turn the cameras on, because they took quite a bit of power for the cameras, plus the scan platform to point it, which had to be heated.
I see. Well, great. My last question would be, you know, kind of a hypothetical one, because Voyager 1 and 2 took care of Jupiter, Saturn, Uranus, and Neptune, and now are exploring the interstellar space. New Horizons recently flew by Pluto and kind of finished the Grand Tour concept. If you could propose to NASA a Voyager 3 mission, where would you send it?
Well, there's some thought being given to that. I think there's a lot of feeling we should head out the nose direction, so that we get outside. But the challenge would be to get there more quickly. So that's a launch vehicle issue. How fast can we get there? This has, after all, been 40 years. It's very hard to plan a mission which the new science, you have to wait 40 years before there's new science. You would really like to have more advanced instruments than we have on Voyager, and so you could do some new science, but the real discovery would be going still further, because you can go faster. We're still very near the heliosphere. We're in the wake. There is a bow wave, if you like, that is created as the sun moves relative to the surrounding material, and we're still in that bow wave. We're not in pristine interstellar space. That's still many years ahead.
I see. But where would you send it? Interstellar space. That would be the prime target.
Yes, I think, understand, you would like to find some Kuiper Belt object, and there are some which could be, just as with Voyager, there were some planetary things to do along the way, and certainly one would look for some opportunities to fly very close to a Kuiper Belt object, of which Pluto is the nearest. And we know that Pluto is very interesting and has had a very active geological life.
I see. Well, to round it up, could you just give me an impression on what it was like to be a main scientist in this Voyager 40-year mission?
Well, you know, science is about discovering things, understanding things, and these missions have been incredible. During the encounters, every day we would have something new, many things new that nobody has seen before. We would spend several hours trying to understand them, and then we had to get ready for the next day when the data would be even more impressive. And so there's a wealth of discovery, and that's continuing now at a slower pace because we're now we're in the very much larger structure. This bubble is very large, but we are still learning things every day. We're collecting data that has never been collected before, and there will be no similar data, we know, for many decades to come, because no matter what you do, it's going to take decades to get back out where Voyager is today.
Great. Boldly going where no one has gone before. Thank you very much, Dr. Stone. It was a pleasure talking to you.
Thank you. Sorry my camera couldn't get turned on, but anyway, I hope you got what you can need for a nice interview article.
Yeah, that was great. Thank you very much.
Okay.
Bye-bye.
Bye.
Bom, essa foi a entrevista. Espero que vocês tenham gostado. Desculpa mais uma vez por não ter a imagem de vídeo dele. A gente bem que tentou, mas a gente tinha um tempo limitado. Eu também não quis perder muito tempo para tentar ajudá-lo lá a fazer funcionar a câmera dele lá. Mas de toda forma foi muito legal conversar com ele e é sempre um momento especial para mim. Como eu digo aí na entrevista, é realmente uma missão que eu guardo no coração, porque desde molequinho eu acompanho as aventuras da Voyager e realmente ela me inspirou muito a buscar essa carreira lidando com espaço e com exploração espacial na comunicação. Então esse foi o programa de hoje, espero que vocês tenham gostado. Deixa aí a sua curtida, faça o seu comentário e voltamos semana que vem com mais Conexão Sideral. Até lá!